Okay, this video is to just get us started on section 9.7. We will finish more of this on Friday, um, but I just wanted you guys to see it a little bit today um, because the juniors are going to be gone tomorrow. So anyway, we're going to be graphing conics again, but this time we're going to be graphing them as polar, the polar version. So we're gonna go back to our way of thinking about parabolas and ellipse and hyperbolas, but we're gonna just kind of put that polar graphing spin on it. So here are your two equations. Um, these look a little bit off, so I'll just move that over a little bit there. You're either gonna have a vertical directrix or a horizontal directrix. The top of the equation is EP for both of them. The bottom of the equation is 1 plus or minus E for both of them. The only difference is cosine versus sine. So a vertical directrix is going to have cosine and a horizontal directrix is going to have sine. Now this plus or minus business, depending on what your equation is, if it's a plus and it's vertical, that means your directrix will be to the right of the pole. We'll talk about what the pole is in a minute. If you have a minus sign, that means your vertical directrix is to the left of the pole. If you have a horizontal directrix, think of a horizontal line. Plus means it's above the pole, minus means it's below the pole. Now, here's what the pole is. So I'm going to highlight it. The focus is the pole. So that's another word for focus is pole. And that's going to always be located at the origin. So right away, when you start graphing, put a point at the origin. That is known as the pole, but it's also a focus. So keep in mind it's a focus. P, if you look at your formula, let me get a different color here. P in the formula, that plays an important role. That is the distance between the focus, the pole, and the directrix. E in your formula occurs here and there. E tells you whether, like, what kind of a shape it is. So if E equals 1, it's a parabola. If E is somewhere between 0 and 1, it's an ellipse. And if E is greater than 1, it's a hyperbola. So that's how you know what kind of shape it is based on E. And then the last thing on this page is that the directrix is always closest to the short side. Okay, now what does all this mean? Let's look at some pictures. So if you are graphing parabolas, do you see how the pole is at the origin and that is a focus? So let me try to coordinate. So I was using yellow for the pole. All right, so that's your pole, otherwise known as your focus. And remember, in a parabola, your focus is always on the inside of the parabola. Now, if you have a horizontal directrix, if your equation had a plus, that would mean it's above the pole, and a minus would mean it's below the pole. So here's an example of a horizontal directrix above the pole. Maybe I'll write that out. Hang on just a second. So, get my pen working. This would be an example of a horizontal directrix above the pole. And this would be below the pole. Remember, the pole is at the origin. That directrix is below it. So in our equation, here's horizontal directrix. That plus or minus, that determines whether it's above the pole or below the pole. So that's also going to help determine whether it's opening down or up. And again, horizontal directrix parabola, E would have to equal 1. So in this equation right here, if the E value is 1, that's how you know it's a parabola. And then you could also have a horizontal, or I'm sorry, a vertical directrix. And that could either be to the right of the pole, or it could be over here to the left of the pole. So if it's to the left, it's going to have a minus sign. If it's to the right, it's a plus sign. If it's above, that's a plus sign. If it's below, that's a minus sign. Here's what an ellipse is going to look like. Again, you can have horizontal above. You could have horizontal below the pole. You could have vertical to the right of the pole, again as a focus, or you could have vertical to the left of the pole. So again, if it's to the right, that would be a plus. If it's to the left, that's a minus. If it's above, that's a plus. If it's below, that's a minus. What else? Just remember that the origin is the pole. It's also a focus. So that would mean that, whatever this distance is, if I went this other way in, there would be another focus. We would be able to figure that out. This comment back here about the directrix is always closest to the short side. What I meant by that is, let's see, let me get a highlighter. Okay, so here's your directrix. If you're looking at where this focus is in relation to that vertex versus where the focus is in relation to that vertex, especially the pole. So from this vertex to the pole and from the pole to that vertex, you see how the yellow is shorter than the green? The directrix is going to be closer to the shorter side, the yellow side. So for example, from this vertex to the pole versus pole to this other vertex, do you see how the directrix is closer to the shorter side? Same thing here, vertex to pole, and then pole to the other vertex. The directrix is closer to that shortest side. I hope that makes sense. I gotta go back. Just remember, P is the distance between the focus, the pole, and the directrix. Pole to directrix is P. Let's write that in here. So here's the directrix, here's the pole, so that whole distance is P. So from directrix to the pole is P. Now this is different from when we first learned about parabolas. We had a P in that formula as well, so it's a little unfortunate that we've got P's in both formulas, but they mean different things. So we're graphing in polar coordinates, which is what you have to remember now. So all the way from the focus to the directrix is P when you're talking polar. And the vertex is still halfway between focus and directrix. So half of this P distance would get you to the vertex. Again, here P is from focus to directrix, so this distance here is P. Again, from focus to directrix is P. Same thing in these. The distance from the directrix to the focus is P. But here's the main thing you need to know for hyperbolas, what I have highlighted right here. The directrix is not necessarily halfway between the vertices. I think a lot of people, like when you graph it and you get your vertices, a lot of people are going to want to put that directrix exactly halfway between them, the two vertices, and it's just not always. Sometimes it is, but not always. So I drew these pictures on purpose so you can see, like, between these two vertices, that directrix is not exactly halfway between them. Same thing here. This directrix is not exactly halfway between the two vertices. Same thing here. So just don't make that assumption that it has to be halfway between. Okay, so we're just going to run through a couple examples and hopefully that'll clear up some of your questions. So here is our first graph. Remember, there's only two possible equations. Either we have cosine or we have sine. In this example that we're doing, sine is the one we have. So that means we're going to have a horizontal directrix. See, we have a sine. So that means it's going to be a horizontal directrix. And we can tell whether it's going to be above or below the pole based on whether we have a plus or a minus here. So in our example, we have a plus, so that means that it's going to be above the pole. And then the question would be, how far above? Well, that's what P is. So that's what we need to figure out. Remember, the pole is at the origin, and that is otherwise known as the focus. So now our job is to figure out what E and what P is. E is going to determine what shape we're dealing with. P is going to determine how far above the pole to put the directrix. P is the distance between the pole and the directrix. All right, so we got to figure those two values out. So look back at our equation. The top of the equation has to be EP, and whatever is in front of the sign, that is your E. Just that's kind of where I start, is I look at the thing in front of the sign, and that tells me what E is. So if we go to our problem, what's in front of the sign? Technically, there's a 1 in front of the sign, so E is 1. And you know how the top of the equation up here is EP? Well, we just figured out that E is 1, so that means in order to make the top of the equation a 2, P would have to be a 2. So here's what we had. On the top of our equation, it was a 2. We know that that would have to be E times P. And I know from looking down here that E is 1. So 1 times what would give us 2? Yeah, it would have to be a 2. So P is 2. So what this means is if E is 1, it's a parabola. And 2 is the distance between the pole and the directrix. And we know the directrix should be horizontal and it should be above the pole by 2. So above the pole by 2, that's where our horizontal directrix should go. And then we're graphing a parabola, keep in mind. And in a parabola, your vertex is halfway between your focus and your directrix. So I know my vertex would have to be here, because that's halfway between my focus and directrix, and my parabola should always be opening toward the focus, like eating the focus, like Pac-Man eating the focus. So my parabola would have to be opening down. And that would be my graph. Let's try this one. Again, this is a sine, so I know I'm going to have a horizontal directrix. And we have a plus sign, so that means that it's going to be above the pole. So the pole is the origin, and that is also a focus. We know it's going to be horizontal above the pole. How far above the pole? That's P. So if you look back at all your formulas, do you see how it's always 1 plus or minus? 1 plus or minus? Well, in this example, we have a 2. So we need to do a little bit of work to make this fit the equations that we were given. So I'm going to force this to be a 1 plus. Excuse me. I have to do it carefully. So I'm going to factor out a 2. So I will factor out a 2 and I will be left with a 1 plus, and then 2 times what would give you a 1 sine theta? 2 times 1/2 would give me a 1, and then this will be sine theta. Now, instead of 3 on the top and 2 on the bottom, I could write it as 3/2 and then 1 plus 1/2 sine theta. So these are congruent, or equal statements. So basically that 2 can go up top, but it'll be a fraction. The reason I'm doing that is so that we can better see what E is, because again, if we look back at our formulas, it has to be 1 plus or minus E, cosine or sine. So I forced it to be a 1 plus or minus. So then that means that E is 1/2. Now, that's going to help me with my top, because the top has to be E times P. So, trying to think of how to make this look nice. E times P has to end up equaling 3/2. That's the top of our equation. And I just found out that E is 1/2. So I need to figure out what P is. Okay, so if you solve for P, you're going to get 3. So what that means is my horizontal directrix is above the pole by 3. So I can go 1, 2, 3, and that's where my horizontal directrix is going to be, above the pole. As far as this 1/2, that tells me what shape it is. So if E is between 0 and 1, that it's an ellipse. So that means that we are dealing with an ellipse. And with an ellipse, I'm going to go back to our pictures. Remember how the directrix is closer to the shorter side of the ellipse? So if I'm looking at my picture, I'm guessing that my ellipse is going to look kind of something like this. Like it'll be a little bit shorter up here and longer down here. Now I need to figure out where my vertices are going to go. I know this is going to be a vertically positioned ellipse because the directrix is horizontal. So I know I'm going to have a vertex up here on the y-axis and a vertex down here somewhere on the y-axis. But I have to figure out where exactly to place them. Now remember, you're graphing in polar coordinates. So think of what angle you would be talking about by placing a vertex here and what angle would be down here. So this would be a 90-degree angle and this would be a 270-degree angle. So what I'm going to do is I'm going to plug a 90 into my equation. So, and I can go back to the original equation, or I can use my modified version, but I think the original was just a little bit prettier. So I'm going to plug in to this original one. So if I put in 90 degrees, sine of 90 degrees is 1. So then that would be 3 over 3, which equals 1. Now, keep in mind, I got a 1 for r when I put a 90 in for theta. In polar coordinates, remember r theta, that would mean I'm going to move 1 toward 90 degrees because the 1 is positive. So that means I'm moving toward 90 degrees. So I'm moving toward 90 degrees, 1. Right there would be a vertex. So now I need to figure out what vertex would be down here facing 270. So I'm going to plug a 270 in. So 3 over 2 plus sine of 270 degrees. Okay, what is sine of 270 degrees? Down at 270, that would be the point 0, negative 1. And so sine would be a negative 1. So this would equal 3 over 1, which is 3. So that means my r was 3 when my angle was 270. So that means I'm going to move 3 toward 270 degrees. Okay, so now I got to scroll back up here. So I'm going to move 1, 2, 3 toward the 270 degrees, and that will be another vertex. So my ellipse is going to look something like that. That's not great, but I think you get the idea. Now, I know if my pole is right here and that's a focus, if that's 1 below this vertex, then my other focus is going to be 1 above the other vertex. So I could draw that in as well. So I knew that because my directrix was horizontal, that my ellipse would be positioned vertically. And so to get the two vertices, I had to plug in an angle that represents going up vertically or down vertically. And up vertically is 90 degrees and down vertically is 270 degrees. That's why we plugged in a 90 and we plugged in a 270. And that gave us our two polar coordinates of our vertices. Okay. I think maybe we'll do one more and then we'll finish up on Friday. Okay, we could look at this one. So again, the first thing I'm noticing is that this is not a 1. Remember way back, our formulas are supposed to be 1 plus or minus. So I'm going to force it to be a 1 by taking out a 4. So if I take out a 4, I'll be left with 1 minus 2 sine theta. Now, I can write the 8 on top and the 4 on the bottom, I can write that as 8/4 on the top, and then 1 minus 2 sine theta. And we know 8/4 is 2. And now this looks more like how our original formulas should look. So we have a sine, so that means we're going to have a horizontal directrix. In this problem, we have a minus, I believe, so that means our directrix is going to be below the pole. Okay, so this will be a horizontal directrix, but it's going to be below the pole because it's a minus sign. Again, the pole is at the origin, aka a focus. So now our job is to figure out what P is and what E is. E is nice and easy. That's the thing in front of the sine or the cosine. So right away I know that E is 2. Now the top of the equation is E times P. So I know that this top of the equation, 2, should equal E times P, and I just figured out that E was 2. So that means that P has to equal 1. So that means I have a horizontal directrix below the pole by 1. So 1 tick mark below the pole, that's my horizontal directrix. What shape is this going to be? When E is 2, if we go back, when E is greater than 1, it's a hyperbola. So we're dealing with a hyperbola. All right. My directrix is going to be somewhere in between my two vertices, not necessarily halfway between the two vertices. Because I have a focus here, I can tell that I'm going to have one that opens up and one that opens down. So if I'm going to have a vertex on this y-axis so that it opens up, I need to plug in a 90 degrees. And if I'm going to have a vertex down here so that it opens down, I'm going to need to plug in a 270 degrees. So let's do that. And you can plug it into this version here, or you can plug it into the original version. That really doesn't matter. Maybe I'll plug it into the original version. I don't really have a great reason, but we'll go with it. So 8 over 4 minus 8 sine 90 degrees. You could go ahead and type that in your calculator and you're going to get a -2. So what that means is I'm going to move 2 away from 90 degrees. So going to my picture, 2 away from 90 degrees would be right here. 2 away from 90. So that would be a vertex. And then we need to plug in 270. And you can use your unit circle or you can use your calculator, and you're going to get 2/3 or 0.66 repeating. So that means I have 2/3 towards 270 degrees. So if I go back to my picture, 2/3 of the way, 2/3 of the way to 1 would be, I don't know, maybe about here. So that would be another vertex. So I have a parabola shape opening up, eating that focus, and then I would have another parabola shape opening down. And you see it's pretty clear that this directrix is not halfway between the two vertices. So just don't make that assumption. And I think we have everything graphed. Oh, we could get the other focus. So this focus is 2/3 away from that vertex. So if we put another tick mark, so just to be clear, that was a -1, this is a -2, this would be a -3. So another focus would be 2/3 of the way away from that vertex. It looks something like that. Okay, so I want to do more examples with you, but I think we'll do them together on Friday. At least this gets you kind of started on section 9.7. Okay, so I hope you watched both the 9.6 and the 9.7 videos and that you will get going on the homework. And be good for Sister Jean. Okay, bye.